Alright, you guys, in this video we are going to look at properties of exponents. I'm calling this pre-6 1 because these are properties that you should have learned in Algebra 1. So hopefully this is a review for you. Alright, so we have 5 properties that we need to understand when we deal with exponents. So the first property is anything to the 0 power, or power of 0, is equal to 1. So, for example, 7 raised to the power of 0 is equal to 1. A variable like x to the power of 0 is equal to 1. And this last one is always going to be for you to try. So please use the power of exponents and tell me what is x cubed, j to the 5th, y squared, that whole quantity, when you raise it to the power of 0, what do you get? Property 2. We're not allowed to have any negative exponents. So no negative exponents. We get rid of negatives by flipping the variable over the fraction bar. So you know how with a fraction we have the numerator and the denominator? I think of it as just changing location, or like it says, flipping the variable over the fraction bar. So m to the negative 3, it's in the denominator. To make this negative 3 turn positive, we just flip it. So instead of being in the denominator, we're going to flip it, and now it's in the numerator. So our answer will be 2m cubed. And I say our answer, I just mean when we simplify it, because again, you're not allowed to have negative exponents. When you move that m to the negative 3 to the numerator, there's nothing left in the denominator, so we don't even have a fraction anymore. The second example is a little trickier because we have x to the negative 7 on top, and we have z to the negative 2 on bottom. So we're just going to flip. The x is going to go below, and the z is going to go above, and this way we'll have positive exponents. The y gets to stay where it is since it's already positive. So on top we'll have y to the 4th, z squared, and in the denominator we'll have x to the 7th. Alright, last one, you try. Property 3 says when raising a power to a power, we are going to distribute and multiply. The distribute part is only if there's more than one term, but we're always going to multiply a power to a power. So in this example, we're going to take the 4 on the outside, distribute it to the x and to the y, and then we multiply with the exponent that's already there. So we have x to the 8th, y to the 12th. All right, in the second example, we're going to take the exponent of 2, we're going to distribute it to the 2, to the x, to the y, and to the z. So we'll have 2 squared, which is 4, and then x to the first times 2 is 2, y to the first times 2 is 2, and z cubed times 2 is 6. So there's our answer. And the last one is a you try. All right, property 4 and property 5. Property 4 says, when multiplying like bases, a base is the big number. So like x, where the exponent's the little number, right? So the base is the x, the exponent's the 3. So when multiplying like bases, we're going to add exponents. So in this example, we're multiplying x cubed times y squared times x to the 5th. The only ones that have like bases are the x's, so we'll add those exponents. So 3 plus the 5, we get x to the 8th, and then y squared. We can't add those exponents since they have different bases, x and y. Ooh, there's not a third you try. So, actually I don't want to give you guys that one. I'll give you another example. For the second example here, Again, 2's the like base, so we keep the 2, and then we add these exponents since we're multiplying the like bases, and we get 2 plus 3 is 5, and then we're going to simplify that. 2 to the 5th is 2 times 2 times 2 times 2 times 2, which is 32. All right, so your example, I'm going to make it, let's go with 3 squared times y to the 3rd times 3 to the 1st times y to the 4th. All right, so that's your try. You try. Yes, I made it a little difficult because you can handle it. And property 5. When dividing like bases, well, dividing is the opposite of multiplying, so since we added exponents, we'll now subtract. Or if you want to think of it as just canceling out, you can cancel out exponents. All right, so in our first example, our like bases are the x's, and so we can subtract their exponents. And you're always going to subtract the smaller one from the bigger one. So since there's the bigger one on top, our answer will be left in the numerator on top. So our answer here is just x. The canceling out thing is, if you wrote it out, x cubed looks like this, x times x times x, and x squared looks like this, x times x. So you could cancel out 1 for 1, 1 for 1, and you see you have 1 left on top. All right, so in the second example, we have 3 squared over 3 to the 4th. Again, we subtract, and the bigger exponent is where your answer is going to be. So the like base is the 3, and then 4 minus 2 is 2. Since 4 is in the denominator, our answer will be in the denominator. We can't leave our numerator blank, though, so we have to put a 1 up there. And so then we simplify. 3 squared is really 9, so it's 1 over 9. Again, if you wanted to, you could use the canceling out idea. So 3 times 3 over 3 times 3 times 3 times 3. And then we cancel out 1 for 1, 1 for 1. And you notice you have 2 3's left on bottom. You multiply those to get 9. And again, you can't leave your numerator empty, so you would put a 1 there. All right, so this last one is a you try. So go for it. The highlighter there in yellow is just kind of pointing out that the 3, the bigger of the y's, is on bottom. Just kind of a hint. All right, and then the last slide for you guys to check out. This last slide just shows all the properties of our exponents, and it shows it in general terms. All right, I hope this was a good review for you, and I'll see you in class. Thanks.